Good morning, everyone. Welcome to the second session of second part of the session, Maintaining and Developing Arctic Observing Capabilities. We had a good session yesterday. We will continue today with 4 presentations, 1 keynote, and then 3 ordinary presentations before we take a panel debate where we welcome questions from the audience as well. And first out this morning is Dr. Craig Lee. Let's see, I think I did put up some information. Senior Principal Oceanographer and Assistant Director for Research at Applied Physics Laboratory of the University of Washington in the US. He's specialized in observations, instrument development, and has a specific interest in upper ocean dynamics, interactions between biology, biochemistry, and ocean physics, and high latitude oceanography. So we welcome your presentation, Craig.
I just first wanted to say thank you for having me here to talk about this today. This is a fairly exciting thing for a large group of us because it's the culmination of a fairly long effort and hopefully the start of a new phase in this. And what I want to talk to you about today is an effort that a group of us, led by Anna Nikolopoulos and myself, you'll see the list of people, it's a rather large group that's been working on this problem. We've been trying to establish an Arctic Regional Alliance under the Global Ocean Observing System, and I'll talk to you about what that is. But fundamentally, right, the idea is that we're at a particular point in history where the Arctic's changing very rapidly. I don't need to talk to this group about what that looks like and why that's important. But it does imply an increase in human activity, right, an increase in needs for information, for data products at a variety of scales. So now we're talking about observations that are serving society, but serving society to everything from very small time scales to kind of the climate scales, which a lot of us like to think about. There are a lot of existing efforts that do this, right, that try to coordinate, but none of them quite span the international scope that we would like, right? Efforts are resourced nationally, often coordinated nationally, and we're wanting for a larger body that helps coordinate. Some bodies are doing this. This group has seen a need for possibly a different approach or a complementary approach. And then right now we have the UN Decade of Ocean Sciences happening, right, in the marine sector, which provides some impetus behind this, and also endorsement from the G7 Futures of Seas and Oceans initiative to pursue this. So what are we talking about? Just to give everybody an idea of the Global Ocean Observing System, this is an effort to develop and maintain a large-scale observing system for science and society. So the idea is an observing system that's tuned to deliver information, useful information to society, also to serve science, right? But to serve a wide range of societal needs. It's led by the Intergovernmental Oceanographic Commission, the IOC, right? It's sponsored by WMO as well, so it has large-scale support from umbrella organizations from above. And it fundamentally tries to coordinate, advocate for, support observing efforts in the marine sector. It's international, right? Has a large group, and it has multiple elements. And those elements include expert panels, networks, and the networks you can see kind of some of the logos are on the bottom there, and if you're in the marine sector, you probably recognize some of these. Argo, Ghost Shipwright are 2 important ones for us, the Global Float Network and the system that goes and takes routine hydrographic measurements around the globe, physics, chemistry, biology, right, through all those, but the Global Acidification Network as well. And then regional alliances, and that's what we're going to talk about today. So GOOS Regional Alliances, these are an attempt to integrate kind of national needs in regional systems into smaller scale units, right, that are more manageable and can be focused on the needs of a region. They can be anything from a national system to something that is actually a coalition of nations are organized around a particular region of the global ocean. They typically focus on a set of priorities that are local in some sense, right? Local to the region. And they tend to be focused on delivering useful products to the stakeholders and rights holders in those regions. There are currently 14 GRAs plus one in the Southern Ocean. And they range from official GRAs under Goose to things like the Southern Ocean Observing System, which are not actually GRAs in the Goose sense, but function as GRAs in the GRA Council. Their organization and their goals vary by region, right? So one of the strengths of these systems is each one is unique. Each one has been tailored to do something particular for the region which it's serving. And that can be adapted by the group that is forming the system. I'll give you two quick examples, one from my backyard. This is the Northwest Association of Ocean Observing System. It's part of US IUS, the Integrated Ocean Observing System. It's an interesting system, and the IUS is funded to actually make observations and deliver data. Not all RAs are funded that way, right? Some of them just do coordination. In this case, US, the National Oceanographic and Atmospheric Administration, has put money into it to actually fund activity at a fairly large scale. But the point I want to make here is that NANUS, the Northwest Association, is a partnership of a diverse array of stakeholders and rights holders, federal, NGOs, tribes, industry, right? All these people form a community that come to the table. It coordinates and conducts observations, and it started small. If you look at this list, and you can't read these, you're not meant to, but the colors are all different kinds of things. Purple is tribal, red is industry, black is academia, green is government. There are almost 80 of these listed here. When the system started, it had about 8. So kind of the first 8 that you see in that list, right? So there's one industrial partner, right? At that point, there are no tribal partners, no indigenous partners. Those pick up very shortly after the beginning. But the system starts small, it delivers something, it demonstrates utility, and it grows into something like this. And the system is governed by that list of stakeholders that you see there, right? So it's kind of a community governance. Another kind of RA is Pacific Island Regional Association, right? This is a group of island nations and some of the larger partners. And this is really just a coordination entity, right? They don't really fund anything, but they try to identify what the needs of the islands are, what the data product needs are, try to pair data providers with people that need data, and try to advocate for the collection of that data. So another kind of structure you can have. So why do we want to do this for the Arctic right now, right? What's the rationale behind pushing for an RA for the Arctic? One of the big ones is to have formal representation within Goose, right? That's a high-level cover. It's advocacy. It's an ability to plan and coordinate at an international level, and then advocate at the national level for resources, because that's where we get our resources, right? They don't typically come in international form, but we need the arguments. We need the larger structure to advocate for some of these more sustained activities. We need to be able to connect existing global observing efforts with the Arctic and encourage them to expand up. If you think about things like the Global Photo Network, ARGO, which is global except for the fact that it doesn't extend to ice-covered regions, into the polar regions, right? This has revolutionized the way that we do oceanography, but it doesn't actually extend up into the areas that we're concerned with. Rather than building our own networks for these areas, right, there's a lot of power in taking our knowledge and our logistics and our community and helping the global networks expand into these areas. One of the things that we're trying to work on is improve the fundamental engagement with rights holders and stakeholders. So we talk a lot about co-production of knowledge. We talk about bringing indigenous organizations and peoples on board at the conceptualization stage of some of the things that we do, rather than at the post-proposal stage. We're looking for partners, right? And those are things that we can start to improve upon through an organization like this. And then there's just simple Arctic representation in a lot of these international bodies, right? Having a seat at the table. So this effort has been going on for some time. It started in 2023 at Arctic Science Summit Week. We did a SWOT analysis, right? Just to see whether this was really worthwhile in the eyes of the people that were in the room. And out of that came a task team to start to develop an implementation plan. One of the messages we got very early on from indigenous groups was go slow, right? We can't respond to something that moves quickly, but if you move slowly, we can try to develop capacity and see whether there's engagement. So we intentionally took 2 years, right, a very long time to socialize these ideas and try to build a bigger tent, try to bring people on board. There's mixed success with that, right? I mean, because you need to demonstrate some utility to get people excited, but we're at a stage now where we have that group, and we're hoping that we can start to demonstrate some usefulness, and that will in turn start to bring other people on board. We got an endorsement from the G7 FSOI. That was a fairly big deal, and that is actually ongoing, right? That'll be part of the announcement that's coming up. Official designation is the task team within Goose and within SAON, so kind of official recognition of the group's tasking its activity, and a home for the products that we were going to deliver, right? An idea that both SAON and Goose are receptive to this idea and would like to implement it. We've had meetings all the Arctic Science Summit week since 2023 and intend to keep doing that. But each one of those has tried to bring on more people, address different ideas and different stages of the process. Writing began in spring of 2025, and I'm happy to say that we now have an implementation plan that we will release for public comment this month in February. And that'll be about a 1-month period for people to respond and comment and give us feedback on the plan that we will then respond to before sending it off to Goose and SAON. So this cartoon was nicely drawn by Hassan from Arctic Passion for us, and it really is meant to kind of illustrate the community. And we use the word community to encompass this large group of stakeholders and rights holders that you see around the ring, around the Arctic. And that's what will form the base of the Aurora, right? That will be the governing body, the council, the advisory body, right? And the idea is to bring in representatives from groups from all these different walks of Arctic observing and Arctic activity to be part of this discussion about how we plan an observing system, how we connect stakeholders and rights holders with data providers, right? How we move this whole regional alliance forward. So objectives. Over the course of a couple of years, we've been slowly refining what we think the actual objectives for the group should be. Fundamentally, it's a coordination organization, right? And the idea is to coordinate plans for Arctic observing, data delivery, what's useful, into a pan-Arctic framework. We have a lot of national coordination, right? Different national systems are addressing different needs. To try to knit those things together, align agendas, right? Identify synergies, what can we do, reduce duplication, and generally help with strategic planning and implementation of a system. Fundamental to this is actually improving the alignment between observing activity and stakeholder and rights holder needs. Right? It can be difficult to communicate exactly what's needed and to pair those needs up with people that can actually provide that data. A lot of times, data could be delivered that would be extremely useful if only the group that was taking the data understood what was needed, right? And that gap is something that is sometimes a need to be bridged. One of the functions we think we can perform. We'd like to be able to grow community-led and community-based observing, right? Fundamentally, some of the long-term observations that we want are going to be best delivered by communities who have been there for decades or centuries, right? They've been observing, they've been taking data, and they will continue to do so, right? But they can be actually integrated into these observing systems, and that activity can be made available to a wider range of people and made more useful. There are issues of data sovereignty, right, and protecting data that come into this. So we've spent years trying to make data completely public and open, and at the same time as we move into that realm, we're going to have to be sensitive to those concerns. What else do we have here? One of the goals, right, is to really start to describe what a core observing system is going to look like. We have a limited pool of resources. We have a lot of things we want to do. How do we decide what the core really ought to be? And we've seen things like the roads, the SAM roads process, societal benefits frameworks, which I think are actually the right path, but we're learning how to walk that path, and it's going to take a while to do enough of it to really start to understand where the core sits. And again, right, this goal is extending existing global networks into the Arctic is kind of a key piece of what we're thinking. So in order to demonstrate utility in the early years, right, we've staged things into near-term tasks and medium-term tasks. We think of the near term as being the first couple of years, and this is going to be a critical period for the Aurora because it's a time when the group is going to have to demonstrate they can do something useful for the community, right, to generate some momentum. The idea is we'll maintain in the annual meeting at ASSW. That'll be a way to communicate with people. There are ideas for beginning to support Indigenous-led observing, and those are things like workshops to start to understand what's needed and adapt technologies to community-based observing. There's going to be a push to extend best practices with Arctic-specific cases and to try to move those into the existing bodies that maintain those databases. We'd like to be able to start to matchmake, develop a capability to matchmake between data providers and groups, stakeholders, and rights holders that need data. There are different ways that we can do this, and it's a big problem, right? So the initial couple of years will be exploring what the appropriate pathways to do that will be. And then the last is to try to create a living inventory, a data flow map of Arctic observations, right? What's out there. We really can't coordinate unless you have an idea of what the scope of activity is. At the same time, historically, we do inventories, right? I've typically not been a fan of inventories because they're out of date as soon as we create them. It's a huge task to do one, but it's an even bigger task to maintain one, right? To understand how things are evolving. And so a big piece of this is going to be to try to create a capacity to maintain a living inventory. And then there's some more ambitious things, right? The defining of a core observing system, the larger engagement of stakeholders and global needs. There is a real need to kind of promote the ICC's protocols for equity and ethical engagement, right? That's something that I think our community is becoming increasingly aware of. I think there's a fair amount of goodwill towards trying to do this, but it's going to take a good deal of effort to bring that to the fore, and that's something we think the Aurora will be able to do. Some other things in there in the long term, a big one is the support of IPY5. And actually, you'd expect that would begin almost immediately, right? The IPY5 is really right around the corner, but we expect it to accelerate in the later years. So in the last couple of minutes, governance structure. Aurora governance, as we envision it right now, and this will likely evolve, is based around a set of shared principles. You see those listed here, right? Open data policy and data stewardship, combined with respecting ideas of data sovereignty, right? How you integrate those ideas and move them forward. Co-production of knowledge. Sustained operation, and the sustained is a key part of this, right? One of the goals of Aurora is to really support the sustained delivery of data. So there are process studies and shorter term things, and this is really focused on longer term activity and the delivery of useful products. Interoperability, right? Developing sets of common standards that we can use for instrumentation, for how data are processed, how data are collected, right? Protocols that can be used pan-Arctic, that will allow data to be shared. And then scalability, this idea that an organization like this will have to be flexible, right? It's going to have to evolve as the stakeholders and rights holders evolve, as our understanding evolves, and as the needs evolve for observing. So to keep it from being too static. This is just the sketch of the governance structure with the idea that you have an Aurora Council at the base of this, and that is the community. It's representatives from all the different rights holders and stakeholder groups that come to the table. Task teams and working groups form under that have a shorter term ambit. They'll be stood up and sunset as needed. That composes a larger Aurora Forum, which will also allow individuals to participate. And then from that are elected a steering group to perform executive functions, and then a project office or secretariat, which is envisioned to be distributed, meaning that it might be people among different groups. Last couple of slides. To contribute to the design process, we've got a website here for the task team. The task team is open to all, and you'll see a list of the people that have been serving on that team over the past 3 years in a second. All you have to do is raise your hand, contact NRI, and we're happy to take your name and put you down and put you to work. The implementation plan will be released very shortly for public comment. Please respond to that. There'll be a survey to fill out, and we'd love to have your feedback. And then there'll be another workshop in 2026 at ASSW. And I'll conclude by a slide that shows the people who've been doing all the work. That is the group. Thank you.
Thank you, Greg.
Thank you. That's a very good overview. We've got time for a quick question or two. Are there any questions in the audience? First turn.
Craig, could you talk a little bit
Please wait for the microphone. There are remote attendants.
Could you talk a little bit about instrument intercalibration?
Sure. That's kind of a favorite subject of mine. As we go to large networks, large distributed sensor networks, right? I'll back up. You can think of intercalibration in terms of shared protocols for water sampling, for how you might do chlorophyll pigments, right, to take a simple one or oxygen titrations. That's a little easier. When you talk about a shared distributed network of sensors, say, choose an instrument, an oxygen sensor that's on Argo floats, for example, right, where the oxygen sensors aren't necessarily as stable as, say, temperature and salinity sensors. How do you make maps of a global network of sensors? Well, one way is you figure out a way to get those intercalibrated, as Phil is referring to. We talked about different methods of doing this, right? You can take a standard sensor and try to run it around different instruments, right? We've done that for things like North Atlantic Bloom experiments to calibrate sensors. So you have a gold standard, you run it and co-sample with different sensors in the network and then use that. You can cross-calibrate, right, when you have chance encounters of sensors. And then you can do clever things like what they do with the oxygen sensor, which is on the floats. They take the oxygen sensor and they get it out of the water. And so each sensor gets an error calibration periodically. They know what that error calibration means, and they can use that to bring the sensors all back into alignment. So it's a hard problem, particularly for things like biological and biogeochemical sensors, which tend to have a good deal of variability and drift in them. But it is, as you imply, Phil, it's critical if you want to do large sensor networks.
Thank you. I think we have to wait with questions then. Keep your questions for the panel debate. I think we can continue then and move on now. And during your presentation, Craig, you introduced the concept of useful data, which is kind of nice to hear about. And also the network approach. So the next presentation is more on the network observatory, or as, how do you put it, inventories. And this is, you didn't like it, but SEON has been working on this. So there is an online presentation made by Alice Bradley, chair of the SEON-CON, Committee on Network, and also Bill Manley, the chair of the Polar Observing Assets Working Group, and Jan René Larsen, that's the secretary of SEON, also at AMAP. So please play the video.
Today I'd like to present on a few activities of the Sustaining Arctic Observing Networks Initiative, or SAON, a study of use cases for observing inventories, and a new resource called the Registry of Polar Observing Networks. My name is William Manley, and I am presenting on behalf of my colleagues Jan René Larsen and Alice Bradley. Broadly speaking, there is recognized need for an integrated Arctic observing system with a means of identifying strengths and gaps, a knowledge map to clarify directions, and ways to build capacity to better meet observing goals. However, the challenge is obtaining a comprehensive perspective across a highly fragmented and distributed landscape of observing efforts. Hundreds of agencies, organizations, projects, and programs observe climate and environmental phenomena at high latitudes, each with its own geographic extent, thematic scope, governance, or funding. Without coordination or improved information sharing, it is often difficult to identify status and gaps and to clarify future directions. To this end, the SAN Committee on Observations and Networks, CON, has a history of conducting inventories on programs and networks. And one of the recommendations of the Third Arctic Science Ministerial was to encourage SAN to update a gap analysis of where Arctic observations are missing and recommend strategies to address priority gaps. This aligns well with one of the CON goals to conduct an inventory of national observational capacities. As part of this, CON is conducting a study of use cases for observing inventories, covering 14 end users. These were identified from responses to a survey, and we will map use cases onto required scope for inventories with regard to contents, completeness, coverage, time period, detail, and participation. For example, with one use case, a researcher new to working at a popular site, coverage can be local or regional. This researcher would want to know what is being measured where, with recent or planned observations, and that the inventory needs to be comprehensive as well as human readable. So envision a postdoc just starting to work on Svalbard who can take advantage of the SciOS catalog, for example. We will look at intersections and commonalities among use cases to arrive at recommendations. I wanted to call out a few resources that effectively share structured information about research and monitoring sites, mobile platforms, research projects, and more. These types of inventories could perhaps be better called observing asset catalogs and include SciOS, ESAFIQ, AOV, RMAP, Interact, and PolarDex. Each of these has an online catalog with maps, lists, and abundant observing-related metadata. Each of these also has a means of downloading the inventory, either as a CSV file for viewing as a spreadsheet, or with an API for machine-readable harvesting to another database. But they vary somewhat in what they inventory, covering, for example, facilities, infrastructures, sites, stations, vessels, projects, and more. There are many other observing asset catalogs, but many of them present details on observing assets only as tables in a PDF or on a web page. And there are many funders, networks, and other organizations that track assets for their own internal purposes, but do not share their inventories. To help promote sharing of observing inventories, the Polar Observing Assets Working Group, POWIG, was formed in 2020 under SANCON to make observing-related metadata more findable, accessible, interoperable, and reusable, the FAIR principles. To act as a bridge between the polar observing and polar data communities, making it easier for organizations to populate, deploy, and share catalogs of observing assets, and reduce cost and effort while showcasing and integrating across systems. Feel free to join us. POWIG laid the groundwork, but funding from NOAA has allowed us to build and release the Registry of Polar Observing Networks, or ROPON. This is a catalog of systems and related organizations that either coordinate or track observing activities and infrastructures at high latitudes, and is available now at polarobservingregistry.org. This is a collaborative effort by myself, Haldor Johansson and team at the Arctic Portal, and Jen Renee Larsen. At the homepage, you can browse, search, or filter for summary cards, one for each network. Clicking on a card leads to a network landing page showing discovery level details, encompassing description, scope, extent, links to associated data repositories, whether this network has their own catalog of observing assets, and links to more information. We currently have 49 networks and related discovery portals in ROPON, which is just starting out. More networks will be added in the near future. Feel free to suggest a network at the website. The idea here is to get a handle on who is doing what, where, which entities have observing inventories, if they share them, and if so, how. So, SeonCon is working to promote the development and sharing of observing inventories, which could better meet user needs. Science planners to assess status, overlap and gaps, network managers to co-locate, for example, with existing power and comms, or to utilize limited resources better. Funding officers, individual researchers to collaborate, data managers to cross-link data to networks and sites, and community members to leverage observational efforts and data collected nearby. This is all the goal. Thank you.
So for this one, we keep questions for the panel debate. There will be sort of the possibility to address SEON and SEON efforts in that context. So I need my glasses. The next presenter is Nigel Jokos. He works at the Department of Arctic and Marine Biology in the Arctic University of Norway in Tromsø. He's professor in statistical ecology and a work package leader in COAT, the Climate Ecological Observatory of Arctic Tundra. And he will introduce us to adaptive management and observation.
Okay, thank you. Thanks for the opportunity to present this center, which is located at the UiT, so the Arctic University of Norway, but which regroup most of the institutions in Tromsø working on Arctic tundra. Like the Polar Institute, and Norwegian Institute of Natural Research, and then Meteorological Institute, UNIS, and then also Aarhus Universitet working on Svalbard. So this center, this Climate Ecological Observatory of Arctic Tundra, COAT, is the main initiative in Norway to understand the impact of climate change on Arctic ecosystems. So we have two study areas. Again, it's a Norwegian initiative. So the Arctic in Norway is, you have Svalbard, which is the high Arctic. And then you have also Finnmark, which is really at the border between the Arctic and subarctic, which represents an interesting area in terms of really where you can have major changes with respect to, for example, forest increase and this kind of thing. So in COAT, in this center, there are really two important components. The first one is really what we call adaptive monitoring. There's been papers written about this by Lindenmayer and others. The idea here is really that we want to focus on attribution, on assessing causes of changes, not just, in a way, documenting changes. And in ecology, of course, in some fields, there has been a long tradition to try to identify cause of change. But in ecology, it's a relatively recent change that's really focusing on causal modeling, on trying to really attribute changes to specific causes. And we want to do this in a fast motion. That is, that you don't wait 5 or 10 years before you get this kind of answer, so that you can really adapt the system to this attribution. The other aspect is adaptive management. What we mean by this is that we want to provide the information to the managers of the system that they need in terms of making better decisions. Adaptive management, it can mean very different things to different people, but here what we implement is what is sometimes called structural decision making. That is, you want to make predictions about the consequences of the action, and you choose the actions based on these predictions. And then, of course, you monitor the system to assess if, in fact, your predictions are, in a way, correct. So that's the two, in a way, crucial part of this center, and this adaptive monitoring and adaptive management. And we want to do this in a timely fashion, that is from year to year. So in terms of both monitoring and management, we include stakeholders at most parts of the, in a way, the cycle when you go from data to acquiring new knowledge. Of course, there are some parts where it's a bit difficult to include stakeholders. I am a statistician by background. It's hard to include stakeholders when it comes to statistical modeling, but it's very important that they are involved both at the beginning in a way, developing the models to understand the system, agreeing on what kind of data is relevant for, in a way, fitting the models on acquiring new knowledge, and then discussing, of course, what kind of conclusions we can reach from this kind of new analysis. In addition, working in the Arctic, we need new technologies because, for example, working with Tundra on so Arctic ecosystems on land, basically we know very little about what is happening during the winter. It's a bit of a pun, but it's a bit of a black box, what is happening under the snow. On something, for example, we have developed in our center is a large system of cameras that operate under the snow during the whole year, so that we have access to what is happening with small mammals, which are a really crucial component during the whole winter. So this is, in a way, new data, but it also implies that we have to think anew in terms of analyzing the change in the system, because before we had only data more or less twice a year or only during the summer, and then suddenly we have data for the whole year continuously. So it means you really have to change the models that you use to analyze this kind of system. So our approach, we are looking at Arctic ecosystem. You are not supposed to read this. This is just a kind of food web, that is who is eating whom in the system. And that's basically the approach we take, focusing on these trophic interactions. Of course, this is too complicated. As a statistician, I would never try to fit a model with so many variables and boxes. So what we do is to focus on some of the, in a way, the main components, what we call modules. Again, in ecology, it's not a new idea. Bob Payne, 40 years ago, had a very nice description of this, is that you focus on some key species, and then all the links that are really important for those species. Just to give you an example, so a species which is very important for stakeholders in Finnmark, so in the northernmost county of Norway, is the ptarmigan, two species, but here I can focus on the willow ptarmigan. And basically, this species, the willow ptarmigan, is really affected by many components of the system. And we have developed an ecosystem-based model, monitoring the relevant components. And then we can make predictions about the willow ptarmigan. And that's what the stakeholders needed. They wanted to have prediction about the willow ptarmigan population in the fall so that they could decide on the quota for hunting. So this is something we have done for the last 4 years. So here you have, for example, the prediction in blue and the observation in, with the curve. They are not perfect. Clearly, there is some systematic error, but the stakeholders, in a way, think this is good enough, at least for the management decisions they make. But we are continuously working on improving the predictions on the forecast. We have done the same thing with NGO, the BirdLife Norway. They focus more on conservation, so not on hunting. On the lesser white-fronted goose, which is shown here, is one of the most endangered species in a way, in Norway and the rest of Europe. There is only one population left in the Western Arctic. And this species is really dependent on indirect in a way, predation linked to the small mammals. So what the stakeholder, again here, the NGO, so BirdLife Norway, wanted is a prediction of the breeding success of the lesser white-fronted goose. that they could use then in terms of field effort, where to focus the work and so on. And we have made these predictions now for 2 years in a row, and more or less they fit quite well with the observations. And again, the NGOs, so the BirdLife Norway, they are really happy about having this prediction before they go in the field and knowing what to expect. So, conclusion. First, there was no program in Norway that could finance a long-term program like this. So we had to, in a way, think anew. It took a long time, but now this center is directly financed by the Norwegian Ministry of Education and Research. So we had to go all the way to the top, in a way, to manage to get this, the financing, because there was no, in a way to do this through the Research Council. This was possible because we had very strong local support by stakeholders, local politicians, and so on, that worked really very hard, in a way, with us, so that we got this financing from the government. And of course, as scientists, we had this long-term investment. This project started 20 years ago, even if the center was opened last year. So it took a long time to get it, in a way, running. And finally, when we talk about infrastructure, I will emphasize that we also should think about the human infrastructure. If you want to have this kind of adaptive process going on, people are extremely important. It could look very nice on paper, but if you don't have the right people to implement this adaptive process, it doesn't work. Thank you.
Thank you, Nigel. Are there questions for Nigel? Ulf, you can take.
Yeah, thank you for your talk. I'm Ulf Jonsell from Swedish Polar Research Secretariat. I was thinking here when you were mentioning ELTER and there is no such program. What about the European ELTER that is now evolving and forming an ERIC? Will this be a part of that? Thanks.
Yeah, we are in close collaboration with the ELTR. I've been at the different meetings that I've had recently. So we are part of the ELTR, but they don't finance anything. So for us, we really needed to have our own financing. ELTR is an infrastructure that is not very... So Norway is half part of it. The Norwegian government is not really eager to finance ELTR.
That's good. Any other questions? I think we have time for another question.
Could you talk a little about how you incorporate modeling of fire and the effects of permafrost of that, if you get the idea?
Yeah, at least on Finnmark, on Svalbard, fire is not really relevant. It's a kind of wet area. We never had fire, or very, very small. So that's not an issue. So permafrost, that's mostly relevant for Svalbard. There's very little permafrost in Finnmark. This is something, in fact, we discussed because we did not expect on Svalbard that the change in permafrost would be so quick. That is, it has really happened in the last 3-4 years, this really huge change in the permafrost. So this is something, in a way, that we missed in the original plan, that we are going really to focus quite much in the years that came. It's really the adaptive part. Things that at the beginning, yeah, we think we should not focus on this, but now we realize that was an error. We could not know.
Thank you. I think we have to move on now, and it was kind of interesting to see your presentation and the workflow. You had data management as a prominent box in your workflow. That brings us over to the last presentation before the panel debate, and that's made by Luke Marston, who will tell us about the SIOS data management system. So Luke is a data manager. He's running the Norwegian ground segment for satellite data in Norway. He's been the data manager of the Nonsense Legacy project, and he's also chairing the SIOS data management working group.
Thank you. It's a privilege to be able to be here and speak in front of so many, such a diverse and accomplished audience. In a world that can sometimes feel divided, Svalbard is in many ways a beacon of hope, a place where scientists from all over the world come to collect data and do their science. But the way we do this science could perhaps be more efficient. We could coordinate better to make sure that we are reducing duplicated efforts and identifying gaps in our collective knowledge. Then I have to work out how to go to the next slide. There we go. That's where SciAS comes in. SciAS tries to bring together 29 research institutions and counting into a single observing system. I'd like to clarify what I mean by an observing system. This means that SciAS is not just a network of people and experts who can communicate and collaborate and share ideas. It has to be more than that. It's a way of coordinating monitoring efforts and taking those observations and collecting them in such a way that they can serve society better than if they were scattered in different places. So there are many people in this room who have probably collected data in the Arctic and some on Svalbard. And often as data providers, we think of our data sets as isolated data sets. But if we put ourselves in the shoes of a potential data user, and I'd class anyone here as a potential user of scientific data, what we really want to be able to do is collect data together over a certain region in a certain time period, and bring all the relevant data we can into a single downloadable aggregated file that we can analyze nice and quickly without having to do all that manually ourselves. This is the end goal, and we should keep this in mind when we're trying to build, to publish data and build workflows for data. Of course, in reality, data are stored in a range of different physical locations all across the world in different data centers. So what SciAS tries to do is bring all those data together and make them available for a single search portal. And this only works if all of this behaves as an interconnected network that follows standards and conventions. So what about other data centers, the ones that we can't see here? Well, there's a few reasons that a data center might not be on this list at the moment. Maybe we haven't got around to adding it yet and there's work in process. But in other cases, there are a lot of popular data centers that you don't see here that are not following rich requirements for thorough and rich metadata, that do not have conventions for those metadata, so we can't gather them together in a harmonized way. Or perhaps they're not serving those metadata in a way that allows us to pull them from the data center efficiently into some harmonized portal. So it's not efficient for us to be able to connect and create custom links between individual data centers and individual data portals. Standards and conventions allow us to reuse software to link different data centers to different data portals. And if you publish your data with one of these data centers, you'll find that perhaps your data are not only available via SciAS, but also available via some different catalogs as well. So this is what it looks like. Our search portal, you can search based on some free words at the top. You can drag some bounding box on a map, provide some time range for your data, or use some of the facets on the side. What we have is as good as we're provided, so this is kind of a work in progress. If people are using different keywords for essentially the same data, we can't combine this into a single search filter. It needs to be harmonized in such a way that we can reliably know what is the same and we can reliably share the same information to users who are interested in it. Central to our efforts to be an observing system is SciAS core data. These are data where we have a commitment of at least 5 years of continuous data collection and providing those data. Sometimes this is a lot more than this. And these have to be key Earth system science variables. We currently have about 69 data sets, I believe, but this is something we're trying to improve. And we want to be able to do something with these data, not just make them available. So these have to have some standardized structure and following best practices for how they're publishing these data. So at the moment, all of the data is in CF-NetCDF, which is for measurements of a physical environment. But we also have a commitment that if people provide data in Darwin Core Archive, that we are supposed to provide the same services on top of this. So Darwin Core Archive is for biodiversity data, although it's been kind of broadened out to measurements related to that as well. And just an example of what we're doing with these data. So this is one example of some soil temperature data in a time series on Svalbard. You can select data from different depths. You can zoom in, you can resample the data, and you can download them into not only NetCDF files, but also into CSV if you're interested in that as well. So by publishing data in a standardized format, you're allowing people to download data in different ways that are not necessarily the way they're stored in, but you can't go the other way. You can't provide data in some custom format and then have the same usability on the data. We can also flip it round and show data as vertical profiles and select different times. I'd like to just take a step back and explain exactly what's happening here. So SciOS is not a data center. We don't host any data. The data are stored at the Arctic Data Center at the Norwegian Meteorological Institute in a CF-NetCDF file. We then provide in the metadata a data access URL, which is an opened app URL. And this basically allows us to stream data over the internet. So you take this URL and put it into your code or your software. And you can build then on top of this. So you don't have to duplicate the data where they're stored, but you can stream them over and provide visualization like this or work with them on your own computer. And I should also say that it's not just SciOS Core data we're providing these services on. If you provide your data and publish them following best practices, then we will also provide these services. It's not just core data that we're doing this for. We can do the same for map data. If we have the web map surface, it's a similar kind of idea, but you can overlay map data on a map, of course. And you can select which variables you're interested in, maybe zoom in and download the data. And with this URL, you can embed this URL as well and put this in your own platform if this is something you're particularly interested in. So I hope I've just shown you a glimpse of what we're trying to build at SciOS and shown you the value in what an observing system can be. It's a work in progress, but it needs us to all behave as an interconnected network for this all to really prosper and get the most out of this. So it's a team effort, not just those involved in SciOS. If you want to find out more about SciOS, you can scan the QR code at the top or search for SciOS Svalbard in your favorite search browser. If you want to hear me talk more about data management, I host a YouTube channel where I share tutorials, discussions about best practices for how to do different data management related things. It's called Luke Data Manager. You can't see it on the chair at the bottom, but you can find that as well. Thank you.
Thank you, Luke.
Thank you. Are there any questions for Luke? Jon Børre?
Thanks. Very interesting presentation. So can you explain a little bit? You say that SciOS is a kind of data portal. It's not a data center, or what you said. So, for example, this SciOS core data. Do they have? Are those SciOS data, or do they still belong to the data providers? So, if you use a data set that you download from SciOS or distributed, do they then have identifiers that are referred to when you use them in publications, for example? Or how is that actually working with SciOS?
Yeah.
Who belongs and who are getting references to those data?
Yeah, so SciOS core data are still stored with different contributing data centers. So those data can be published and have their own citation, and the data providers should absolutely get the credit. SciOS don't own these, but we're trying to work together to try and get the most out of those data. So we have identifiers and recommended citations for these. And these are not, again, exclusively going to appear on SciOS, but also elsewhere. And SciOS is also more than just a data portal. I chair the data management working group as part of this, so I'm kind of focused on this. But there's also collaborations in remote sensing working groups, in communications, and I'm going to get a shot for forgetting the last one. Logistics as well, yes, thank you. So SciOS is more than just data, but data is a very important part of SciOS.
I think we are good now with this. We can also take questions in the panel debate. So I would like to end this part of the session and then ask the participants in the panel to join us in the stage here. So we've set up a panel for the remaining part of this session. And you've seen all of them during previous presentations in the session. So it's Nigel, it's Craig that presented today, and it's Kate and Matthew that presented yesterday. And in order to start up the discussion here, we've given them some questions up front that they should introduce themselves with in the discussion now, and then we have some follow-up questions and welcome questions from the audience as well. And the two main questions that we ask them up front, so that you know that, is what is also given your presentation, what are your viewpoints on what a Pan-Arctic observing system is? That's one perspective. And the other one is, how do you see your work as part of a sustained, coherent observing system that compromises local to regional features for societal benefit? So those were the two questions. Oops. And perhaps see you are holding the microphone, Craig. So do you want to start on that?
Let's see, so where do we start here? The first question was, where do I see my work in as part of a Pan-Arctic observing system? And there are two aspects of that, right? One is what I talked to you about today, and that has really been an effort by a large number of people, really, and something that we identified prior to the pandemic, right? The idea of trying to bring forward an Arctic Ocean Regional Alliance to sit within GOOS is really over a decade old. And so this group kind of formed up and saw this need for a broader coordination body, a body that would help connect internationally with these larger systems, and decided that it was a good time to push for that. Right, and there are a number of reasons for that. I talked about those in the presentation about the Aurora. So that's that's one place where I see my work. The other place is I do a lot of ocean physics at a variety of different scales, instrument development in support of that. And a part of that is developing large-scale pieces of infrastructure. Things like the acoustics that would give us underwater GPS, which is really a crucial element of being able to make year-long observations under the ice in the Arctic and in the Southern Ocean, and small-scale robots, right? And so that there are two elements of where I see that sitting. you know, the system itself, I think, is really a combination of very hyper-local things, right? And those are, a lot of the community-based observing, the long-term observations those are our biggest hope for having really long time series, right? Really long records of variability and elements that we can see being brought forward into the larger system. At the same time, the larger system has the ability to offer useful products, right, to stakeholders. If we can make those connections to see what they are and to build those systems. Fundamentally, all this is resourced at a national level, right, which is the reason for doing the international coordination, because you have these various national efforts. Occasionally we'll get a multinational effort going, right? But these things tend to be ephemeral, right? They're funded on a 3 to 5 year basis, which is not a great way to fund decadal sustained observing. And so there's this effort to join that smaller scale, shorter time scale activity with a larger overarching scope that will help set strategy and keep things going in the long term.
Thank you, Craig. Perhaps, yeah, Kate, do you want to go?
Sure. I can talk about this a little bit from the opposite side of the scale, maybe working in a really hyper-local context. And I think about larger observing networks as this fitting together of a whole bunch of stuff that's happening across scales, which is the beauty of it and also the complexity of it and also what is so complicated about all of this. But I mean, I work a lot on network analysis and understanding risk and resilience. And when these little parts are put together in a good way, that's what builds resilience. And that's what creates these long-term processes where we can really better understand what's going on. And so it's like the two sides of the same coin of this, like looking at these large systems and understanding how there's so much potential and opportunity, especially when engaging people across all scales, and then also the challenge that comes with that, especially when you start encountering and dealing with issues of data sovereignty and how all that fits together. And where I see myself or my work or people that work in similar capacities that I do fitting into this is keeping research sovereignty, keeping indigenous sovereignty is really central to these questions when it comes to how to integrate across scale and across a pan-Arctic observing network, and then also how to maintain a connection to local values. Because values are so place-specific. Our work is so place-specific, and understanding how these values connect or don't throughout this entire system, I think, is a challenge, but once again, also an opportunity when you're building like places and systems in which you really need a lot of participation. And so understanding where values fits into that entire system, I think, is really important to the long-term success. I'll just pass it here.
Okay.
You're right next to me.
Yeah, I have to agree with a lot of what Craig and Kate just said there in a lot of context. My work is more at the local scale, maybe not hyper-local, but definitely local. And I think, to Craig's point there, like the sustainability of these decadal-long observations, I think it's just so critical that observations are done at the local level with local priorities and goals in mind. So that's really the focus of our work, is to really lean in on the co-production and the co-management of science. We're contributing to these larger networks. Of course, we do have instruments that are deployed, throughout the different areas that can be fed into these larger pan-Arctic networks. But the goal of our work is really to focus in on the more local level to respect the place and the values of our partners that we work with. I was going to add some challenges, but maybe it will come up here in a later question. So.
Okay, we'll have a slightly different perspective. We work on ecosystems, and climate is clearly the most important driver of ecosystems. It means that we collaborate closely with climate scientists, but it means also that we need to measure what is relevant for ecosystems. For example, for us, snow structure is really the critical parameter. It's also critical for indigenous people and so on. We know very little, in fact, about change in snow structure. We know a lot about snow extent or snow depth or snow melt, but snow structure is really poorly known. So it's when we collaborate this kind of network, it's really important also that we refocus on what is important for the system. Another aspect is that working with ecosystems, we don't have like people working with the atmosphere. We don't have state variables like temperature, pressure. We have many species. They are complicated, and even there have been attempts to develop the essential biodiversity variables. These variables often are not relevant for local communities or indigenous people. So which means really that it's a problem that is you develop this international network, but local people don't see the interest in participating to it. So if we want this network to be successful, we really need to combine this local relevance to the international networking, and it's not easy. I think right now in the Arctic there are very, very few places where, in fact, we more or less manage to do this.
Thank you. You can just keep the microphone for now.
Okay.
I think this is a very good introduction. We now have this sort of perspective from the local scale where you get a good engagement with the sort of end users of many of the things. But you also have the perspective of the large scale, which is needed in order to get funding, to get awareness, and some sort of attention at a different level. I think COAT is a good example of it. It's not purely a local scale. It's still have this sort of a larger scale perspective. And in this context, how do we work towards maintaining and developing the observing capacities individually, together, or across scales? So how do we connect the dots to make a whole out of the information that we have here? So perhaps, Nigel, you would like to start on that?
So for us, it's really strengthening we have already some collaboration, for example, with GEM, the Greenland ecosystem monitoring, and we have close collaboration with the Bylot ecosystem monitoring in Canada. So we really need to strengthen on having this on a more permanent basis with Canada, Greenland, Norway. Now, of course, the big hole in the system is Russia. It's the elephant in the room. We had close collaboration with Russia. Of course, now it's a bit difficult, but it's half of the Arctic. So this is something for us which is really critical.
For the marine sector, there are a few things we've been thinking about fairly intensely. The first, if we go to kind of the local scales, is trying to understand pathways for co-designing and co-executing local observations out of communities, out of Arctic communities. Examples include work that's going on the North Slope of Alaska right now, trying to collaborate with the community of Utqiagvik to collect measurements of fast ice and breakup of fast ice right off the shore, and to create tools that the community can actually use that are surfaceable on a local level, right, that could be used to collect these observations and bring them back to the larger network. There's another effort that's ongoing in Baffin Bay, has been for a while and is picking up steam. But so those are efforts that begin on the coastline and are very tightly tied to community needs. With that are efforts that are not as tightly tied to community needs, but also important in the deep basin, right? Pan-Arctic observations, say you wanted to measure heat content in the global Arctic, or you wanted to look at ecosystem change, how that changes as the sea ice changes, right? And those are again, they're difficult because they're fundamentally international, but they're going to be resourced nationally, right? Nations will have to come forward and contribute to these larger scale systems. And so those are kind of pieces of the puzzle we're trying to put together right? And how you coordinate those international pieces, and then how you tie them back to the coast, right? Because what happens in the middle of the basin actually has an impact on the coast, and how you create predictions, right? So those are just some random pieces of the puzzle that the marine sector is trying to pull together.
Do you want to go first? Or?
Please,
Okay.
yeah.
I have trouble like thinking how to answer this question without immediately going to like, here's the problems we have. And from my perspective, from my quite local perspective, I'd been working with the New Natsiavut Government Research Center for a while and looking at all of the researchers who had come through and filled out their research approval process for 10 years, and then went back and tried to find that data. And try to find those researchers and to see what happened with that data and why doesn't New Natsiavut have access to it? Because in this case, there was a research agreement which that access was part of it. And this is just a really small case study. Happy to share it with anyone who like it's up and published somewhere. But it's I think it's a really good place to look at some of these smaller things that happen that get in the way. And so even just, us as scientists are really, really bad on a personal level of like figuring out how to make our metadata, how to do these tables, how to make it interoperable, how to describe what we did in a way in which things could be done again in the same way. Like we're not very good at that. And when it comes to like a lot of students that come to a place and do research, which hopefully that data would get integrated into a larger project, into a larger observing network, that data gets lost. That data it goes away when that student graduates. All of these little tiny minutia, little things that people, individuals have control over contributes to big data gaps in these larger systems. And so spending the time, which is the stuff that generally you're not even paid for as a student or as a professor, as a researcher, to really make sure that these things are harmonized and can function, is so critically important. And I think we need to put a little bit more value on that process to make sure that these bigger systems are functional.
Yeah, when I think about that question, my mind still goes towards the community aspect of things. And I have to say, like, during this session, it was just incredible to hear the amount of times co-production was brought up. I mean, it's a term that even, 5-10 years ago, you wouldn't hear it very often in a conference. Maybe this conference is a little different, but more broadly, it just wasn't as pronounced as it is now. So that's great. However, there's challenges. I think we all recognize that. The co-production, it takes time and it takes resources, and to convince funding agencies to allow the research to go at a slower pace, to engage at the speed of which co-production takes place is critical. Our project that I'm a part of, we're very fortunate in that our funders allowed us a full year and money to do that. And so, but we are in the minority of projects that where the co-production was something that was put forward that the funding agency supported. So we have a lot of work to do to convince the funders to support this type of science. So I think that's one. And then two, and Craig, you brought up a point that kind of came to mind is, when we're trying to connect all of the Arctic, I think there's also an issue of over-researched and under-researched communities. There are communities who are tired of researchers coming in. They're at capacity. They don't have time at the tribal councils to talk with the researchers. There's just too many. And a lot of folks are being turned away. But at the same time, there's a lot of communities that are underserved. And so I really liked what you had to say in your talk there at the start of it. To avoid duplication and to be better coordinated. I think that's something that needs to happen at all levels. Not just the actual research itself, but the coordination of where research is being done. So these are really big issues. I don't have the answer, but, but maybe one of the other panelists or the audience does.
Well, there are good questions, anyway. I think there are a couple of things that have popped up now, like harmonization of observing protocols, harmonization of data management, and things like that that could be dug into in further detail. But before we move on, are there any questions to the panel or comments at this phase in the discussion? Anyone that has perspectives to add to what has been mentioned from the stage here? Do we have the mechanisms to actually do things to move from the local to the global or to the regional scale? Are there things missing?
So I advise on a project in Eastern Canada, and it's completely designed and implemented from the local people and coordinated with Scripps. And the thing that I've noticed in the observations as it's developed over the last few years, one of the key things was when the villages got Starlink. And that allowed them to interconnect with the other villages that were doing similar work and with other people outside of their area. It allowed the data to be quality controlled. So I just wanted to mention that was a big game changer in how we engaged with local communities. And it also enabled more remote education with the data being coordinated from off-site and on-site, and the educational outreach, not just from the people collecting the data, but into the local schools. So I wanted to touch on the issue of just the ability to communicate the data among villages and the capability that that's brought, which has really been a game changer for what I've seen with the Native communities.
Anyone in the panel that wants to?
I'd love to. I couldn't agree more. It's the same circumstance with a lot of the villages in Alaska, remote Alaska. Starlink was absolutely a game changer, and it has increased our efforts to sustain the connection, right? Like over time. So it's not just in the summer when we're doing field work where we're able to engage with the community. So that has been incredible. I hope. I do fear maybe that it could be a double-edged sword. Like if there's too much reliance on the remote connection, that there's the risk of losing that in-person aspect. So that's something that we're very cognizant of in our work, to try to do the community visits and extend them out as long as we possibly can to maintain that in-person collaboration. I think that's where the trust is built. Which is just a critical, I think the most critical part of this co-production aspect in working with communities is that trust that's built. So, but I couldn't agree more. I think it's a game changer. The only downside that I see personally is that now I have to look at emails when I'm out in the field.
Anyone else that wants to comment? I may have a question in this context, because of the engagement of the communities, you need the local scale to actually achieve that pretty good. But how do we then ensure that we have harmonization at the larger scale? So anyone in the panel that has any perspectives on that? Do we have the mechanisms? Do we need other mechanisms?
Take a little bit of stab at that. So there's been a move towards trying to define best practices within various communities, right? Whether it's protocols for how you take a water sample, or whether it's standards for how you take and record temperature or sea level. These things are fraught because, right, best practices aren't really defined by somebody deciding this is a best practice. Best practices are really defined by something that works, that people adopt because it helps them, right? It's productive, and then that becomes something that can be established, that you can share. But fundamentally, that becomes really important. Phil asked the question about how you intercalibrate sensors in a large sensor network, right? Which is a subset of this broader question of how you might standardize methodologies and ways of recording data so that you can intercompare. I don't have a great answer for that, except We're thinking about doing this within the Baffin Bay region within communities as part of a distributed biological observatory in that area, and trying to start to connect communities across the Baffin Bay region. It's interesting because it's a smaller area, right? So it's a little more tractable. And it's an area where there's some motivation to do the interconnection, because what happens in the southern communities is something that may eventually sweep north and happen to the northern communities. And so there's a way to motivate that talking to each other and sharing of data, and hopefully a sharing of practices. So we'll see what happens. But that is one of the things that's come up, is how you standardize the data collection and make it all intercomparable.
I can add my ecosystem perspective. The United Nations has developed an ecosystem accounting system that is really try to standardize looking at ecosystem conditions around the globe. But basically, this ecosystem accounting system is useless in terms of local management and so on. That is, you produce something that the managers cannot use in any way. And that's really, I think, a big problem, because it's really hard to in a way, get local people to support, or local politicians to support a system like this when they cannot use it. It's, in a way, it's perhaps good, I don't think so, but perhaps good to look at the whole Earth, but clearly it's not adapted to, in a way, the problems that people have today in this context of really quick changes and so on.
Thank you. Any comments from the audience? Luke?
I work a lot with a lot of individual scientists who are out there trying to do their best, collecting the data and standardize everything. There's a lot of really good work that's going on. At the same time, I see that it's really hard for these people, because it's a kind of completely new thing that they've got to learn that 10 years ago they were not really expected to do. And then also, I'm concerned that the term fair data has become a bit of a buzzword, and people just borrow this and apply it to anything where they mean open access or some open sharing of data. And this is not what fair is. And I guess my question is, how do we educate the world to fix this problem and move towards a more interoperable data scene? What can we do to encourage this and allow people to set time aside or funding aside? And yeah, how do we fix this problem?
Anyone in the panel that wants to start on that?
I can start with Quat as the data are fair, follow the principle, and they are open access and so on. We have a very short embargo just after the field season. So for us, it has been a very important aspect of developing Quat. As most people know, the funding for having this data management and so on is often, I think, underestimated. That is, it takes really a lot of money. It takes good people that really implement this. So I think in many research projects, the data management, you have to write it fair, blah, 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 as you said. It's a buzzword. But to do it well, and so that it's when people want to use the data, they can, that's in a way undervalued.
I guess I would second that, speaking as a, just from the perspective of an individual investigator, right? It's the resources that it takes and the professionalism it takes to do that haven't been valued historically within the community, right? And so part of that change is actually getting to the point where you budget properly for it. You have people that do that and who are respected for doing it, right, and have a pathway for doing it. I think we're slowly moving in that direction, at least in the U.S., but it's been a painful process.
Just an anecdote to add to this, I guess, a little bit. I, with a colleague, recently did a survey of a lot of graduate students that were collecting data and had been collecting data in indigenous territories. And one of the questions we asked was, what kind of training did you receive to understand how to appropriately shepherd data, whatever that is, from collecting all the way to disseminating to putting in a depository, whatever the case may be, whatever shepherding is in this case. And not a single person, several of them had taken an online course on the First Nations principles of OCAP, which is ownership, possession, access, and control of data. I'm very bad at acronyms. I'm so sorry if I messed that up. But that's the principle. So it's like understanding these larger concepts, but then there wasn't not a single graduate student had gotten any training on how to do that, what the processes. So understand the principles, sure. Understanding the processes, no. And so I see a really big gap there, especially in education, which then just kind of recapitulates across the entire system over time as people move onto different positions. So from the bottom up perspective, I guess I see this as a particular issue.
Yeah, I'm not sure if it's directly addressing the question or not, but the thing that came to mind is at the start of this project that I'm currently on, I was responsible for setting all the sub-awards, and there's a lot of paperwork that's involved, and the data management plan is one of them. It's something that I thought would be one of the quicker documents, but it was honestly like a 2-month process of back and forth, a discussion with the various partners and communities on the project. So that really stood out to me, like in hindsight, it shouldn't have surprised me because it's very complex when we talk about data sovereignty and what we want to share, what we don't want to share, and so that was a piece of it. And the other piece of it was a lot of the data that was collected. It was in the formats and in the structure that best serves the community, and there's really not the drive to share it at a larger, broader audience. So that's something that we're dealing with on our project right now, is to make the data that is shareable into formats that can be shared at a wider audience. It takes a lot of capacity, and I think that's to all the points of like actually funding that work and allowing the expense to have an expert to do that. That's a critical piece of any project.
I think these are good comments, and it's also, I think, timely to look a bit back as we are approaching the next International Polar Year. I think that during the last International Polar Year, that was the first encounter of many scientists with the concept of metadata, data about the data. And what they understand by data about the data is the discovery level. But the use level, also how to actually interpret the content of the data, that's something that we've not addressed fully yet. So perhaps that's an ambition for the upcoming Polar Year, to fully embrace the 2 last letters of FAIR, also the interoperable and reusable. I think that's also very good comments here. Oh, sorry? Yeah.
I have another perspective, and a little bit continuing on your answer on the ELTER. It's very true that, and this is a European perspective question, I think, it's very true that many of the environmental infrastructures, the ERICs we have, they do not fund the hardware or the human resources doing the field work. And it's more of the top, maybe the data portal, the coordinating, and we'll be talking a lot about coordination here. Sometimes I think it would be easy if we can have a single-sided infrastructure somewhere in the Arctic, like a CERN or a European Spallation Source, and the community would come together. And those communities, I mean, in physics, they are very strong. They understand this, and they need to work together. So, for instance, as a suggestion, I think in the new European Framework Program, there's I don't know what happened to the suggestion, but that there should be 20% even for investments of in the infrastructure from the European sources. So what do you think for this community? Are we prepared to come to this stage where we do the pooling these resources for investments and not just building on the distributed infrastructures on the resources that are there, because that is also giving up a little bit maybe on the control of the nodes that we are running and such? Or what would it take for the community to, if we could say that, be like the physicists, for the particle physicists to really strive for this huge investments that are needed? Thanks.
Anyone that wants to start on that?
I guess part of the response to that would be that, we're not the physics community, and that it's when you talk about building a particle accelerator, the place you build it doesn't really matter, right? You can bring everybody together in one place. If you're building a telescope, you're looking at one place where you've got a good view of the sky and people can come. But if you're talking about environmental observing or looking at Earth system science, particularly in the Arctic, right, the place matters quite a bit. The place where you're making the observations, it varies, the importance, the connections to the community, the needs, and just the physical variability matters a lot. So the distributed infrastructure is really an important part of achieving the scientific goals and achieving the societal goals. Makes it harder, more complicated.
I think we are running out of time, and by that you also addressed partly the geopolitical perspective that we didn't dig into now. Also, that's complicating in the Arctic, going from North America through Europe and Asia. So, but anyway, I say thank you to the panel, and final comment?
Yeah, if you don't mind some shameless plugging for just a moment. If any of you are going to be, because data sovereignty has come up so many times in this conversation over the last 2 days, the first day of the Arctic Science Summit week, I'm co-hosting a full-day workshop to really get into these issues of data sovereignty and working across scales and how to go from the hyper-local to the cross-Arctic, and to crowdsource best practices, but also better understand the challenges. So it's open to anyone, and I'm sure there's going to be a lot of early career researchers that have a lot of experience directly in place-based questions. And so I just want to put in that plug. If anybody would like to participate in that workshop, please let me know, and I'm happy to do that.
That's a good final comment. Look into the AOS program and look for sessions that suits your needs in there. Thank you to everybody.